Hello, this is Innovice's InfoSewer program, and I'm Bob Dickinson, and we're going to talk about how to use the advanced force main support in the newer versions, post-2012 versions of InfoSewer. The little toggle for advanced force main support is under simulation options, and it applies only to the EPS simulation. So if I was to try to run this with steady state, it says invalid split flow configuration because you can't have two downstream force mains coming out of the same chamber node. So how do we get around this? Well, really there's really only one way, and that's really to get rid of the invalid splits. So we'll use deactivate. So we'll deactivate some of these links. This link over here, this link over here, all these links. So now those are deactivated. Now we'll go ahead and run this in steady state. And it ran. So now we have our steady state model. So if you look down here at the flows, click on graph, we can see the graph. Click on report, we'll see the report at a particular time for that particular steady state. Actually, since it's steady state, it's all the time. What are the flows that we can have in steady state? Well, if we look at our loading manhole, basically our options are, you have up to 10 loads. The loads can be unpeakable, peakable, base, peakable coverage. If it's unpeakable, it's just like a standard constant flow times the pattern. And what determines how the peakable works is you go over here to simulation again, go over to peaking, and you set in a peaking factor here. So this is your peakable point load. Just takes the flow that you enter here, raised to a power times a coefficient, and then that gives you your peak flow. If you don't want to use this, you can use an alternate peaking curve. And with the alternate peaking curve, you can set up a set of different coefficients for different flows. Or you can use a peakable coverage load where you have population, and population would be over here. You would have population, and then put in a peakable base flow or peakable coverage flow, you enter the population here. So again, that's under simulation options. When you look at the report, the report tells you what the total flow was, what the unpeakable flow was, what the peakable flow was. If you have any coverage flow, it tells you that. If you have any infiltration, it tells you that. Storm flow, whether it's pressurized or not. The velocity, the D over D, the Q over Q. In other words, in this particular case, the Q over Q is a lot more than full flow. Full flow is based on Manning's equation, and in this particular example, the flows or the slopes are very small, so the flow is pretty tiny. This is the water depth. This is the critical water depth based on the Froude number of 1. Here's your Froude number. This is the full flow. As you see, it's a lot less than the flow. Is there any backwater here? No backwater. Adjusted depth. There's always some confusion about adjusted depth. Basically, adjusted depth is there's two passes in this solution. The first pass puts in the water in the nodes, and the program figures out what the flow would be in the links based on the loading in the manholes. The second pass is to take those flows in the links and the loading manholes and figure out if there's any backwater occurring, any pressure, etc. And that's the adjusted depth. If the adjusted depth is greater than the depth, it means that there's backwater or there's pressure or some kind of reverse flow is occurring. So this is the basis of advanced force main, at least in a steady state. Part 2, we're going to look at advanced force main for the EPS. Thank you for